Hi everyone. Yeah, you can hear me. That's nice. Welcome to my session, hot module replacement, or as I like to call it, preventing burn injuries caused by hot module replacement. My name is Stanimira Voeva. I work at Progress, and I'm developing NativeScript. There, I'm working on the Angular integration, some performance tips and tricks to improve your startup time. And lately, I've been doing quite a lot of Webpack. Like the hot module replacement thing, it's a feature provided by Webpack. We will see some Webpack examples today. I hope that you're not scared, because that's me, and that's a Webpack error right there. But as you can see, I'm not scared. I don't cry anymore when I see these errors. I just got used to it, and that's all right. How many of you use Webpack? That's cool. For the rest of the people, that's good as well. Yeah. All right, so this is going to be a kind of weird presentation. It will be a bit like a play. So the first act is called manual replay. And the scene will enter a NativeScript developer. And because I don't have any actors or anything, it's going to be a monologue. So, sorry. And the NativeScript developer says that NativeScript is great. Actually, yeah, may I have introduced NativeScript first. NativeScript is a mobile framework that you can use to produce mobile apps, native mobile apps, by using web technologies. How many of you know NativeScript? Sorry for asking so many questions. Quite a lot of people. Cool. Yeah, that's for the recording, actually. No one raised their hand, but doesn't matter. So NativeScript is great because it works both on Android and iOS. You can choose from the most popular web frameworks out there, or you can just use JavaScript to write your code. And also you can share your code between web and mobile. So you can have a single project and produce multiple apps for different platforms. But sometimes the development experience with NativeScript can be a bit not what we expect it to be. Let's see what I mean. We have a simple mobile app here. We're navigating to the login screen, and then we're trying to sign in. Eventually, we are signing in, and then we go to admin page, a page that is protected, and we can't go there if you're not logged in, right? Then we go to the code and make some change. I'm trying to change the text that we see here, and the change should be applied on the screen. So what actually happens when I save the file is that the whole app restarts. I'm back to the first page. I go to the login page. I sign in again. This takes some time. And finally, I see my change. So what's the problem here? Someone? Yeah, the problems are a lot. I lost my state. I'm not logged in anymore. It's kind of slow because I have to sign in again. And here's how this whole reload cycle looks like. I make some change. The app restarts. I try to replay the steps to manipulate the app back to its old state. Then I see the applied change. And then I have to repeat the whole process again and again when I make other changes. So basically what we're doing here is manipulating the app back to its old state. And this is bad because on one hand, I'm modifying the code. I'm working on it. I'm thinking about it. Then the app restarts, and I have to do something else. I have to log in again. I have to navigate and stuff like that, just so I can see my change. And this can completely break your flow, because you're doing two things. It's slow, and it's terrible. But we can fix it. Let's take a step back and ask ourselves a few questions. What if we didn't have to restart the app? What if we replaced only the module that we actually changed? What if we could reload only the current page that we're in? Let's see in that perfect scenario how that would have looked like. I'm signing again. I can see the admin page. Then I could go and make some change to the code, probably the same change, and I can see the change applied instantly, almost. make another changes, and I can actually see them. And this is great because I can just keep doing changes and make sure that I don't break my flow, right? That's called hot module replacement. And it's really cool. Just a quick note here, HMR stands for hot module replacement. Like replacement, not reload. Just make sure that we're on the same page, you know. And it's not magic. I'm gonna explain how it actually works. And that's gonna happen in the second act. It's called partial reload, because I couldn't think of another fancy name. And we have a couple of scenes here. Actually, there are 3, but I say a couple when I want to say a few. That doesn't matter as well. So just a note, and again, this is not how Webpack actually works. But you get the right idea. It's abstraction of how it actually works. So the scene enters Webpack. And Webpack says that every JavaScript file in our project is a module. Also, every HTML file is a module. Every CSS file is a module as well. And if you get where I'm heading, pretty much everything is a module for Webpack, except for what's not a module. And all the modules will be bundled together by Webpack. And what is the bundle? In our oversimplified case, we'll think about the bundle as a simple JavaScript object. The keys are the paths or the names of our files, and the values are some functions. And these functions wrap the code of the file, right? And that code can be pretty much modified during the Webpack build process. For example, if you have a TypeScript file, Webpack can transpile the file to JavaScript while it's compiling it. What if we have another file in our map, and that file depends on app.js? Obviously, we don't have app.js anymore. We only have the stuff that's inside that map. So naturally, Webpack will go ahead and replace the require with a query to the modules map. And here, we're going to get the function that contains the code. Simple as that. Again, pretty inaccurate how it actually happens, but this is the abstraction. All right, we know how the app is built, and now we're going to figure out how the actual replacement happens. We have quite a few actors here: the hot module replacement plugin, Webpack, and the developer. The job of the developer is to make some change to app.js. The hot module replacement plugin generates a hot update, and the hot update, you can think of it for now just as a function that wraps the new code, the changed code. And then Webpack will replace the changed module. The module again, the new module is contained inside the hot update. What happens here? That was our map. Webpack replaces the code of app.js with a new code. And the module that was depending on app.js now points to the new code. This is cool, right? So what we did so far, we didn't restart the app. We had a single JavaScript object, and we replaced some stuff inside it. Yeah, we replaced the module. But what we didn't do is to actually apply the changes to our application. We replaced the code, but no one was notified of that. So here comes the third scene. I promise it's the last one of this part of the presentation. So here the stage enter Webpack and the developer. Webpack says that every module should have an update handler. And if it doesn't have an update handler, it won't replace it. This is a bit tricky because we should have a fallback mechanism. It's all right if some module doesn't have an update handler. It won't be replaced by Webpack hotly. So we need to handle that and just restart the app. But we need to be aware that such modules can exist. OK, the developer says, no problem, I'm going to write the update handlers, everything's going to be fine, it will work great, but I don't really know how it works yet. And the cool thing about Webpack is that it has a great documentation on hot module replacement. I'm not even being sarcastic here. So let's see how we can we can write update handlers. The first way to do that is by self-accepting the change. So inside the module, we can simply use the module hot accept API. We need to add that single statement to the module, and it will be accepted. What will happen is that the module will be executed anew. The new code will be reevaluated. And the other tricky part is that its parents won't be notified about the change, and then they won't be reevaluated. Let's say that we have this simple hierarchy here. We have full.js, and bar.js depends on it, and so on and so on. We make a change to full.js, and it is self-accepted. So Webpack goes ahead and asks full.js, do you have an update handler for yourself? Full.js says, yeah, I'm self-accepted, everything's fine. And Webpack goes ahead and executes full.js. But its parents are not notified. So when is that okay? Let's see how we can write some reloadable code that can be self-accepted. The first important part is that we shouldn't have any side effects. And this world is not perfect, and I can't write actually code that doesn't have any side effects, so at least we should be aware of our side effects. Let's see an example. We're creating some button, and we're attaching an event listener to it. Yay, this works. So we're creating a new button, then we have some event handler, and we're attaching an event listener to our button. And at the top, you can see that the module is self-accepted. So if you make a change to that code, it will be executed again and again and again. So what will happen is that we're going to add new event listeners every time we execute that code. And that's not cool, because we'll end up with so many event listeners, and we'll see like 10 console logs when we tap the button. And this will eat our memory, and this example is really simple, but the world is complicated, and this can lead to some really, really bad things. So how do we fix that? There's one way to do it. We can just attach the listener to the global object, and it will stay there until we replace the code. Then we can check if we already have a listener and attach a new listener, only if we don't have some listener, right? It makes sense, and it will work in this example, but just don't do it. And there are multiple reasons, just two reasons. We can change the event listener, and it won't be reapplied, right? Another thing, we can have many, many side effects, and if we wrap all of them in such if-else statements or something, this won't look really nice. If you attach a lot of things to the global object, this won't be cool as well. This code will stay there when you build your production bundle, and a lot of other reasons. So just don't do that. I think we're doing that in NativeScript, but ignore that. So the right way to do it is to use the hot dispose API. You can attach a callback here, and the callback will be invoked whenever the out module is replaced. The idea is to remove any side effects that your out code caused, right? So we can just go ahead and remove the out event listener. The new code will be executed, and we're going to attach a new event listener. And we're sure that it's clean and simple. And we can do quite a lot of things in the dispose thing. We can save our state. We can remove the old state, stuff like that. All right, is everything clear so far? Thank you. Cool. Is everything not clear? Okay, I'll take that as yes. It's not clear, but that doesn't matter. So the second thing about how to write reloadable code is to take care of your parents. I'm not going to read that. So how do we do that? Let's see an example again. That's our old code. And we know that there are some other modules that depend on our module. Here we have the bar.js module, which just requires the full JS. And we have bash.js, which requires bar.js. And we want to reevaluate all of the modules because they can contain some important logic that should be executed whenever the first module changes, right? How do we do that? There is another API that you can see here at the bottom module. And again, it's hot accept, but we can provide an array with the dependencies of this module that should be accepted. And again, we can attach some update handler. So why is that important? That's a parent accept. You saw the API already. And the important thing is that the whole dependency chain will be reevaluated. Everything there will be executed anew, and the new code will be applied. And then the callback will be executed. And that's really helpful in some cases. How does that look like? We make a change to full JS again, but it doesn't have a self-accept. We have a parent accept in the bottommost module. So Webpack will go ahead and ask full.js, do we have an update handler for full.js? We don't have. So we're going to go to its direct parent, bar.js, and we're going to ask, do you have an update handler for full.js? Again, we don't have an update handler. Then we're going to go to bash.js, and the important thing here is that we're going to ask, do you have an update handler for your direct dependency? Not for full.js, but to bar.js. Because the third module is importing the second module, not the first one. And we do have such handler. So Webpack will execute the whole dependency chain starting with full.js. Then it will execute bar.js. Then it won't execute the last module, but it will execute the update handler. So that's it. And it's kind of complicated, isn't it? That's why in NativeScript, we've been working on that hot module replacement feature for the past months, I think. And we decided that we can just do that for our users, and they won't have to write that code themselves. And this is cool, isn't it? OK, so what is left? I think I have plenty of time. And as I said, I'm working on the Angular integration with NativeScript, so I'm going to talk a bit more how the hot module replacement works in Angular. Let's see an example. We have the same app, but it's built with NativeScript Angular. We go ahead and make some change. Just to pause here, I changed this text here, right? We save the file. And nothing happens. Interesting. So we make another change, and nothing happens again. And at this point, we're kind of pissed off already, but still, nothing happened to our app. All right, maybe we missed something here. Do you remember like 3 slides earlier when we said that we from NativeScript were so cool and we're doing that for our developers? Well, that is true, but probably didn't see that here. You can't read it, right? Yeah, OK, I'm going to zoom a bit. So we're going to handle everything unless you're using Angular. Because Angular is super cool. And we love it. We all love Angular. Who loves Angular? Yeah, everyone. Everyone, yeah. Me too. Cool. So to make Angular work, we need to do some additional steps. And actually, I'll use the moment to show some other pretty cool things that you can do. No matter what framework you're using, or if you're using no framework at all, you can still apply these steps to improve your hot module replacement experience. Cool. First, we need to apply the changes, obviously. No one does that for us in Angular. Even if we're using Angular for the web, you still need to apply the changes somehow. The first important thing is that in Angular we have one root module. And every other modules, and by a module right now I don't mean an Angular module, just a file. Okay, we have one root file. And all other files depend, I like dependencies of this file. Eventually it's like a tree structure, and at the root is just a single module. So we're accepting all changes in that root module. And we have a single update handler for the whole application. Again, it's the same for the web Angular. What we do next, in the update handler in our root module or file, we're bootstrapping a new Angular app. And because the new code is replaced, we're bootstrapping the new app with the new code, which is cool. Now we got to take care of the old app and we just dispose it. There are some ways to destroy the created Angular modules. Cool. Let's see that in action. Just a second. I've got the same app here. Can you see stuff? Probably. I'm going to run the app because it crashed right before the presentation. That doesn't sound very encouraging, right? It's all right. So it's an Angular app, but it's for mobile because it's a NativeScript app as well. And I have done the steps that I showed before. I have the new evaluation and new bootstrap of the new app. Let's go ahead and make some changes. For example, in the home component, we don't have anything here, so I'm going to go to the HTML. And here we see the HMR demo text, which is in the action bar. So let's change that. And nothing happens again. This is our root file. It's called main.ts. So the truth is that I have commented some of the things. And we're going to see how we can actually do the thing, do the persisting of routes and states. Okay, let's go back. As I said, as I showed, actually, this demo will fail. But we have a few more. All right. How do we preserve the state, the route in Angular? It's pretty simple. We should save the route somewhere, for example, in some file, before the load starts, and then we should restore it. We can navigate back to the route. This is some code which is not really important, but in NativeScript we have something called onBefore wivesync. Before the reload starts, we're getting an instance of the router, and then we're getting the current URL. And then we are caching the route. Okay. Then after the reload finishes, after wivesync, as we call it, we're getting the router again, and that is a brand new router. We don't have any navigations inside it. And if we have a cached route, we're just navigating to it. The idea is to go to the same page that we were before. All right. So the fancy code that we saw, I have it here in this file that's called persist route. And I'm going to start the application because we made some change which affects the reload cycle. So we need to restart the application, unfortunately. And this takes some time because Webpack is super fast, really. All right, let's go to the home component again and change something. And again, yeah, it worked. Cool. Probably didn't saw that, but okay, let's make it. Can I spell that? Yeah, cool. Super cool. I know Bulgarian. Can't believe it. All right, we have the hot module replacement working. But what happens if I close the app Then open it again, and then navigate to the About page. Let's change something there, for example. I'm gonna make the size smaller. Nope, we're back to our old page. The reloads didn't really work. Okay, what about the state? Let's go here again and log in. And try to log in. Then I can go to the admin page and change some stuff here, like make the text smaller. And the app didn't restart, but I'm back to my old page, right? So if I go to the login page, I'm not signed in. My state is gone. So we need to fix that, because I don't want to sign in every time on every change if my page is protected. All right. Basically, what we need to do is just preserve the session of the signed in user. And the idea is simple again. It's pretty much the same thing. We should save the session before the reload starts, and we should restore it after. And we need state management. Like, we don't actually need state management, but people are using it, so it must be cool. So I'm going to use it as well. But the question now is, what state management library should I use? Should I use Redux or NGRX or NGXS or anything of the other 500,000 state management libraries out there? The right answer is it doesn't matter. All of them have some way to preserve the state. So I chose to use something kind of new. It's called Akita. And the reason behind that is that, I mean, look at the logo. When I see that logo, that's what I think. It's just so cute. But seriously, Akita is awesome, and you should give it a try. And it's super cute, right? All right. So we should save the walked-in user in some session. And then in Akita, we have two really simple things. The query, which is like a getter for our session. We can get the user. And a session store, which is like a setter for the session. We can update the session store when our user signs in. Here's how that looks like. It doesn't matter again, but yeah, I'm going to show it. So before the wipe sync or the reload starts, we're getting our current session, and we're caching it, right? After the reload finishes, we're getting the store. Again, the store now is brand new. It's empty. It doesn't have any users or anything inside it. And if we have some cached session, we're just updating the store. That's all that should be done. There are similar ways to do that in Redux, NGRX, and the other 1,000 state management libraries. Cool. Let's see if it works. I hope it does. You see at the time taking pauses at the right moments, just so you can enjoy the GIFs. Cool. So I have another magical file that contains the persist state logic. And I'm going to rebuild or just restart the app again. And something with the route may not be working, but at least our user should be walked in. Cool. Let's go here and make some change. Yay, the route is persisted, which is cool. Let's make another change just to see if I'm not lying. Okay, we're on the same page, which is good. Another important thing. So if I try to go back, just to summarize what happened. We didn't restart the native app, right? But we did bootstrap the Angular app anew. and we lost all of our navigation history. Then we directly navigated to the About page. That's why if I try to go back, I'm just going to close the app, because we don't have the navigation stack. That's totally expected, right? So I'm going to go ahead and close the app. There are ways to fix that. I'm sure you can do it. For example, you can replay all the navigations or just persist the whole navigation stack. All right, I'm trying to log in, and I hope this works. I'm signing in, then I can go and make a change to that page. Let's make this bigger. And I'm back on my old page. Uncool, uncool. I'm gonna try to start it again. Just wanna make sure that I have everything enabled, persist state, and persist state includes the same thing that we saw on the slides. We are getting the current session, caching it, and then we are applying the session. Probably somewhere. Yes, we are applying the session again. Cool. I'm gonna close the app and then restart it. And if this doesn't work, I may have lied to you. Okay, the app is starting. We're trying to log in. Once again, we see the old change, which is good. We make some other changes. Yeah, and we're on the same page. So probably it was some wife sync issue. All right, let's change something more. Yeah, we're still here. It does take some time, but that's because I have enabled all the logs and stuff for debugging. Yep, it works. Cool. So I can just say that all my demos worked and everything's fine, right? Cool. We should be happy because we persisted our state. And in our case, we just have a single user. But we can have quite a lot of things in the state of the app. Actually, the current route is also some state. The navigation stack is also a state. We can persist everything before the reload starts, and then we can reapply it. So I'm calling that manipulating the app back to its old state, but automatically. So that we don't have to sign in again. Our code does that for us. Yeah, I just love that. Whatever. So for the finale, here's what I can say. The hot mode replacement can be tricky sometimes. It doesn't work all the time, especially if you're using some framework which tries to handle it for you. But it's good to understand how the inner APIs work. Like the Webpack APIs, they're just 3 APIs, right? Self-accept, the parent accept, and also the dispose. So use hot mode replacement, it always works, right? Thank you.